The natural world is not only a set of constraints, but also of contexts through which we can more fully realize our dreams. That's a quote by Paul Shepard. Today I'm going to be talking with you about the context of 3 different systems thinking methods. My intention is for you to be inspired, gain some new insight into each of these methods. I'm going to start out by talking about cognitive thinking. There's a type of cognitive thinking that's particularly useful for systems thinking. And we're going to talk about that in a little bit. But first of all, let's talk about cognitive thinking in general and how psychologists came out with this concept, this notion. Cognitive thinking was first thought to be a linear process. There was a stimulus, and then a thought process, and then a result. Then they added more to it. They added both deductive and inductive processing loops. Their original idea was that cognition or cognitive thinking takes place in the mind, so it's strictly a mental process. But then the behaviorists had a problem with this because they thought of cognition as having to do with situatedness, and they behaviorists thought about there being a stimulus and a response, simply that. Well, so there was a conflict there between the cognitivists and the behaviorists. Well, in 2017, some researchers came out with yet some more information about this. They went from the classical cognitive model to the enhanced cognitive model. And in this model, they added 2 more boxes, one about the physical and one about the environmental. This whole idea encompassed both the mental processes that take place in the mind, as well as the body interacting and manipulating the physical environment. So this enhanced model had to do with taking advantage of both the mind and the body when it comes to cognitive thinking and explaining how this works. Probably the best example I can give you is about the fictional drama series Murder, She Wrote. In this series, the main character is Jessica Fletcher, and she's a mystery writer, and she goes about solving mysteries that take place in the community. She will look at a lot of crime reports. She will interview suspects, but what really helps her crack the case usually has to do with just mundane objects that she comes across in the environment. Things like a cigarette lighter or a napkin. It could be anything. The point is that it's this interaction she has with the environment on a physical level that makes the difference in her being able to do this. So this is a really great example of this overall idea of cognitive thinking. Now let's talk about the specific case of it being for systems thinking. In 2023, this year, the researcher Chowdhury came out with this idea. This idea is about particularly managers being able to apply systems thinking without resorting to different methodologies and procedures that are very rigid that have to do with systems thinking. Because when that's the case, then it's very difficult. You have to learn the methodology and get proficient at it. However, to just be able to apply systems thinking more broadly, it was a much more attractive way to go. And it much easier to do and much more likely to be applied. That was the big point. And so a key to this is a concept of holistic flexibility, which means that systems thinking that you can be very flexible both in intent and form when you're applying it. Chowdhury gave a couple of use cases that we're going to talk about, but first of all, the key to this, to be able for him to do this, was this idea of holistic flexibility, where he was able to integrate to different levels. That it's possible to integrate different methodologies. But what he's really advocating is the full amalgamation or full mixing, where really you have these different methodologies, but then you integrate them together so that it's one seamless approach. And he demonstrated that this worked effectively through two use cases. One was a public relations company, and the other was a steel manufacturing firm. He studied this public relations company, and he found that they really needed some advanced technology to help them. They were not communicating and collaborating very effectively, and so they needed this so that the different geographic regions would be able to do that. And they also needed their human resources department to institute some training so that everyone could be brought up to speed on this. The second example involving the steel manufacturing company was a situation where they had different problems. In this case, there was a lot of different departments that were divided up, and they worked like silos. They didn't really work together too well, so it was hard for customers to get their steel products. It was hard for them to get them delivered on time. The whole process was difficult. So they restructured and they reorganized, and they really focused on creating a setup so that they could truly provide value for the customer. In each of these cases, there was three key factors that made all the difference in their effectiveness. First of all, the overall approach was different because it incorporated systems thinking into it. The second major factor is that they involved the major stakeholders. That's what you have to do if you really want something to be implemented. And the third factor is that they had a very high level of connectedness in their recommendations. They didn't just have discrete recommendations and some of them contradicted the others. It all worked together. So this was key in having this whole thing work out so well. It was really head and shoulders above most business analyses. My next method I'm going to talk about today is design thinking. Design thinking is particularly geared towards satisfying the user and making the user happy. At its very highest level, systems thinking and design thinking are really quite a lot alike because they both involve looking at the big picture and intentionally creating a certain result, creating something or solving a problem through deliberate intention. As a process, design thinking has 5 steps, and they are empathize, define, ideate, prototype, and test. And these 5 steps, the experts get together to do this, repeat these iteratively in no particular order until they produce a prototype. Then they test the prototype on the user and see if it works out. A great example of using this design thinking process happened at GE Healthcare. They had an MRI machine that they were using to run these tests, these scans on children, but the children that were having these tests done, it was bad for them. It was really a lot of loud noise, a lot of blinking fluorescent lights. It was cold, it was dark, and they just cried all the time. So it was bad. So what they did is they totally redesigned the machine, and so that it had a pirate adventure theme. And now the kids loved it. They were 90% happy now. So this was great. The scans were a whole lot more accurate, and the technicians saved a lot of time and energy. So the company was very happy. It was a win-win. The third method I'm going to talk about today is system dynamics. System dynamics is all about looking at the interaction of different objects in a system. A system can be anything from a car engine to an economy. In 1961, J. Forrester applied system dynamics to organizations to improve their effectiveness. System dynamics has feedback. That's a big part of it. And I'm going to give you some examples. This first example is about new product adoption, and there's potential adopters and adopters, and when the potential goes down by one, the adopters goes up by one. So it's all interconnected. The second example has to do with a question of how severe is a disease in a particular day, for instance. And so key to that would be, of course, the infection rate. And there's a few other examples I can give you that I think are good uses of this process of system dynamics. And one of these is taking a look at the interdependence of wolf and elk populations in Yellowstone. Another one would be managing the inventory levels in a factory effectively. Now that would be a good use of system dynamics. Then there's supply chain management of the food chain, maximizing the effectiveness of the food chain. That would be one of them. And the last example is to be able to reduce the energy usage in an automobile plant. All of these are good uses of system dynamics. They're good because you can clearly define the variables. They have a clear scope and clear goals, and a lot of these, it works best when there's a closed system. The next thing I want to do is talk about the pros and cons of each of these methods, or at least we're going to touch on this. In terms of cognitive thinking, the biggest plus in this case is that you can actually apply systems thinking and be free from all those rigid rules. But on the downside, you might make the wrong assumptions, and you might have certain mental blocks, or there's a lot of biases that can get in your way too. There's a attention bias, for instance. Another bias is the halo effect, where you think that everything a person says is true and is accurate when it isn't. But probably the biggest drawback is that in cognitive thinking, it isn't really specified exactly how you do this. I mean, you know that you're looking at the big picture, you're looking at patterns and the interconnections of the key elements of the system. You know that, but what exactly do you do? You might want to start with Derek Cabrera's DSRP method. That stands for distinctions, systems, relationships, and perceptions. You'll need to add some other methodologies depending on what it is you're doing. You'll need to add them in, but this will at least help you get the ball rolling. In the example I gave earlier, where the researcher Chowdhury, he used several different business methods to be able to come to a good answer to help those companies. In design thinking, the biggest plus you have is that you're catering to the user, and you're actually creating something for the user or building something. The downside of design thinking is that you can't really use it for radical innovation or long-term innovation. The closer you get towards pure research, it just falls apart, doesn't work. But probably the worst drawback of design thinking is that the experts involved in this process might end up leaving out certain data that they really should include. Another point to make here is that users, this is catering to users, but users do not always know what they want. Think about when the PC first came out. In 1974, there was the Altair, and there were hobbyists that got together in garages and people's living rooms to tinker around with it and play with it. But it was more of a toy. It didn't really do anything for people. It wasn't until Steve Jobs promoted it as a business tool that it really started to take. Plus, for system dynamics, or one of them, is that when you have a clear scope and clear goals, you can use system dynamics to gain some real insight into complex systems. The downside is that a system dynamics model can only run one version of a system at a time. Now, all the variables that are in this model, well, those can change a lot, but just one version of it is all you can do at the time. Probably the worst drawback when it comes to system dynamics is that it looks really scientific, but that can be deceiving. Almost anybody these days can use one of these system dynamics programs and crank out a whole lot of material. Is it any good? Well, that's a good question. Let's take a look at this example. This is an example of teacher retention in schools. If you look really closely at this model, you will not see any variable that has to do with the administrators, the superintendent, and the principal. Now, I happen to know that the quality of the leadership of these administrators has everything to do with whether a teacher can be effective or not and whether they stick around or not. There was another researcher named Burrs who in 2019 looked at a lot of these system dynamic studies, and he came across one that had to do with dairy production of milk. This study did not include any variable having to do with cows. Not a good model. This kind of misses the point there. Finally, I'm going to talk about some factors you really need to pay attention to. I've talked about each of these three system thinking methods and the context that works well for them. And I've talked a little bit about the pros and cons of each one. And they each have a lot of different factors that fit into this. They have a lot of different factors and a lot of different nuances. But these are three factors you definitely want to pay attention to. And if you do, then you'll be able to at least get your arms around these three concepts. These are scope applicability. Does it apply at a narrow scope, a medium scope, or a very vast scope? Does it, are the action steps ambiguous or clear? And the results that you produce, are they tangible or intangible? First of all, let's take a look at this cognitive thinking. And let's say you're doing cognitive thinking for strategic purposes in a company. And let's say you have people down there on the production line producing a product. Even they need to be aware of whether what they're doing is in alignment with corporate strategy, even at that level. And then, is it, in this case, are the steps ambiguous or clear? Well, in this case, they're probably pretty ambiguous. You're going to have to figure those out. And in terms of whether it's tangible or intangible, well, when you're coming up with a strategic plan, what you're doing is setting the stage for what's going to happen next, whether it's producing a product or whatever it is. So your goal is to produce intangible results. In the case of design thinking, your scope is probably very narrow. You might be trying to produce a new product, for instance, come up with a new product. So the steps, while they're not completely ambiguous, they're a little bit ambiguous. You've got these 5 steps. You just keep doing that, and you will come out with the result. In terms of whether your results are tangible or intangible, well, your goal is to produce a prototype. So, of course, that would be tangible. In terms of system dynamics, your scope applicability in that case would either be narrow or medium. You would be a few steps removed from the actual tangible result, but it's closer to it. And in terms of the steps, whether they're ambiguous or clear, that's probably the clearest of the 3 in terms of action steps, because once you set up the model, that's pretty much how you use that as it is, and so the steps are pretty clear. So this grid will help you be able to look at these 3 and help determine which of these will be best for what you're doing. Okay, now let's summarize. Today we talked about 3 different methods of systems thinking. We talked about cognitive thinking, design thinking, and system dynamics. We looked at the different context that works best for each of these. And we also looked at some of the pros and cons of each of these. When you think about cognitive thinking, the good news about cognitive thinking is that it applies to a small situation or a very big situation, and that so different levels of scope, and also you can include different levels of scope in the same analysis. So that's a big plus. It's important to keep in mind that there's all this hype these days about artificial intelligence. That shouldn't take away, though, from human intelligence, from cognitive thinking, because this is still a very valuable skill. We know a lot about how the mind works, and I've talked about in the beginning how the state of that knowledge has increased even recently. But still, we don't fully understand it. We just know that it works. Now, on the downside, in terms of cognitive thinking, when you get a group of experts together that have a special functional specialty, it may be hard for them to broaden their thinking to the system level. They may need some education and training to be able to fully take advantage of that method. We also talked about design thinking today, which can be good for incremental innovation. What you do is get a group of experts together. They're focused on can they help that user. That's the focus. And they are committed to producing a result, which will be the prototype. However, the danger is that they might leave out relevant data. And another problem that could come up is that users sometimes they can't even visualize what it is that they want. The third method we talked about today is system dynamics. When you've got a very clear scope and clear goals, when you've got a closed system with very well-defined variables, in certain specific situations, you can get some great insight into a complex system. However, keep in mind that just like cognitive thinking, assumptions, biases, and beliefs can get in the way. It looks very scientific, and you can crank out all kinds of material, but how good is it? Well, it depends on how good the modeler is, really. It looks a lot less subjective than it necessarily is. It has the same subjective failing as these other methods. So keep that in mind. If you want to come out with a new product relatively quickly, you probably want to take advantage of design thinking. If you want to improve the efficiency at a factory or track the progress of migratory birds, system dynamics is probably the way to go. If you have a large corporation, you're trying to stay innovative, trying to stay competitive for the long run, cognitive thinking will probably be your best choice. In any of these situations, it's important to consider the context.